Good morning, Amy. How are you doing?
Good morning, sir. I'm doing well. How are you?
I'm good. I'm good. So last time we were talking about area of sector, right?
Hmm.
Area of chord we also did. And of course, we did arc length and all of the things.
Right.
We're basically working with radian measurement and everything revolves around the circle for now. Have you understood this concept?
Yes, I have. I've tried questions from my book and also just some exam questions. And yeah, they're following the general rule that you discussed last lesson.
Any difficulties so far?
Yeah, not really. Yeah, I think this topic section so far has been a bit like quite straightforward.
Correct.
Yeah.
So what I actually did, I know that you have understood the concept and we have gone through some examples. You have also solved questions from your book to some extent.
Hmm.
But now, as you see, we really are preparing for a year 13 exam, right?
Yeah.
So what I did was is that there are some other exams which are equivalent to yours. Normally, the international students who come to me, they share with me those questions, and
Hmm.
I find Cambridge International something written there. So, and I find that these are relevant to you, not really the same which you will be looking at. But if you look into those questions, they can help you understand what you are doing much better. So I thought
Hmm.
I'll share with you some of these questions and we'll look into their solutions today. And you'll help me out to find their solutions. Is that fine?
Yes, perfect. Okay.
So let's take it like a, mock test, right?
Hmm.
Where both of us are being, trying to understand how do we solve these difficult questions which are seen in test papers, right?
Right.
Because when we normally work, we have a lot of time to work and things are much simpler. But in exam, all of a sudden, we find very, very difficult questions. So if we have the real questions, they'll prepare us for exam, right?
Right. Yeah.
So are you ready with your formula, the calculator? Remember, we need
Radians.
radian measurements. Okay, so you're there.
Yeah.
Because
And
I don't have a calculator here to work with. I do have, but I would like you to do all the calculations if required. Perfect.
yeah. Perfect.
So what I did was that these are the questions from Cambridge International previous test papers. I've given reference for each and every question here. So there are many questions which I copied because when I look into things, I look into great details. I mean, you understand.
Right. Yeah.
So there are quite a few questions here, which about 11, which we can look into. I do have their solutions also, but we'll actually try to find the solutions ourselves for some
Yeah.
questions, correct? And I think that is going to help many other students who are doing the same thing, right?
Definitely.
Who
Yeah.
are in year 12 and in year 13. I'd like you to read the very first question and then we'll try to see, or rather, find a strategy to solve it, correct?
Yeah.
We'll not
Okay.
exactly solve it, but we'll write the strategy on the side. Perfect.
Perfect. Yeah.
Okay. Please read question number one.
Okay. So the diagram shows a triangle OAB in which ABO is a right angle AOB is a fifth pi, and AB is 5 centimeters. The arc BC is part of a circle with center A and meets OA at C. The arc CD is part of a circle with center O and meets OB at D. Find the area of the shaded region.
Is the question clear to you?
Yeah.
Perfect. So how will you find the area of this shaded region? Tell me.
Mm-hmm. So I'll be thinking, so I'll find, this is just a general strategy, so just maybe find the area of the triangle,
Perfect.
find the area of those two sectors, and then subtract.
So beautiful. So area of the triangle ABO, which is a right angle triangle. So basically, we can just find that area of the triangle. We know one side AB given to us as 5, right?
Fine. Yeah.
We know this angle given to us as 1 by 5th of this. So we can
Fine.
find OB, right? So
Yeah.
OB will be what? So OB, because this is tan theta, correct? So you can find tan 1/5 of pi is 5 over this angle. So you can find uh, OB with the help of tan theta, correct?
Yeah.
We know tan of pi by 5 will basically be equal to AB over OB, right?
Mm-hmm.
So we know OB for us is what? OB is equals to AB divided by tan of pi by 5, correct?
Yeah.
So we know OB now. Since we know AB and OB, we'll just multiply OB and AB and
Divided by
divide
2.
them by 2 to get the area of the triangle. So we get the area of the triangle. Perfect.
Yeah.
Once we get the area of the triangle, we need to now find what is the uh, area of those sectors, correct? These two sectors,
Mm-hmm.
so that we could really take them out. So this sector, we know r theta. So we have to now find the other angle. So the angle A will be what? Pi by 2 minus fifth pi, correct? So the
Yeah.
angle A will be pi by 2 minus pi by 5, correct? So you know the angle A. Once you know angle A, then that is your theta. You can multiply this by 5 to get the area of this sector, right?
Wait, so I got angle A, but then
Yes.
why did you times it by 5?
R theta, area of sector.
I thought area of sector was half r squared theta.
Yeah, half r squared. Yes, yes, you're right. You're right.
Oh,
So I was taking the half r squared theta. You are right. So half of 5 squared theta. Yes.
all right.
Area of
Okay.
sector. You're right. So you will find that, right? Now,
Mm-hmm.
similar, you'll find the area of this particular sector. And once you use these, take away these two areas from the triangle itself, you get your solution, correct?
Oh, yeah.
Is that clear to you? Yeah, this is how you'll do, right? Can you summarize how are you going to do, please?
Yeah. So our strategy was to find the area of the triangle
Yeah,
and then subtract the area of the sectors to get that shaded region.
right.
So to find the angles that we're missing, we just used tan, the opposite over adjacent, and then we found the sector area using the formula of half r squared theta. And to find that angle A, because we've got the 90 degrees and the angle O, we just add those and then subtract it from 180 to get angle A.
Perfect. And that is how you're going to solve this particular question, right?
Yeah.
So we have used the sector area formula to find this area. Can you please read question number 2 and suggest how will you solve this question?
Yeah. So the diagram shows a triangle OAB in which angle AOB is 90 degrees and OA is 5 centimeters. The arc AC is part of a circle with center O. The arc has length 6 centimeters and it meets OB at C. Find the area of the shaded region.
Okay. So how will you approach this?
I was just going to say a similar thing with the area of triangle and then
How will
just
you
area
find
of
theta?
sector.
Here we don't know theta, right? Last time we were given the angle. Now how do you find theta?
Right. So we've got the 90 degrees. Oh, we've got the arc length.
Yes.
Oh, A equals
6
r
equals to
theta.
r theta, right? 5 theta, correct?
Yeah, I just saw the arc length. Yeah.
Correct. So whatever. So once you know theta,
6
this
over
is kind of
5.
easy, right? You get the
Mhm.
idea? Perfect. And since we know this is now, we know this angle and we know that particular side, we can always find the bigger length, O to
Right.
B, and then we can solve the area and do as we did. So what you see here is question number 1, 2, 3, 4 have very similar strategy, correct?
Oh, okay.
You find
Yeah.
the area of the sector, the area of the triangle, work with these and get to the solution. Is that clear to you, right?
Yeah, really clear.
Right. Now, let's look into question number 5 and 6. Now, question number 5 and 6 also look very similar. The only thing is it seems as if 6 is kind of half of 5, correct?
Yeah.
More or less, right? So we can discuss
Oh,
the
yeah.
solution of 6, right? Then, it is like, if I divide it like this, kind of, do you understand? It becomes question
Yeah,
number 6,
yeah.
right?
I didn't think
So
about it like
from
that.
the symmetry, we can definitely get the solution of 5 from 6, right?
Yeah, yeah.
So let's discuss how do we solve question number 6. Can you please read question number 6?
6. So the diagram shows a circle with center O and radius r centimeters. The point A and B lie on the circle and AT is tangent to the circle. Angle AOB is theta radians and OBT is a straight line. Part A, express the area of the shaded region in terms of r and theta.
Okay.
And part B, in the case where r is 3 and theta is 1.2, find the perimeter of the shaded region.
Good. How will you do this?
So part A first.
Yes.
We're trying to find the area of the shaded region.
Yeah. General formula in terms of r and theta. Yes.
Yeah. So because we got the little sector, we can find, and they're leading in terms of r and theta. So you can just find the sector area, which would just be half r squared theta. And then the triangle would be, so we've got theta and 90. Can we just find the area of the triangle by finding AT?
Yeah, so tan theta can work, right? Because that's the side opposite to this, right? So tan theta is AT over r, correct?
Over r,
so which gives you AT as r tan theta, correct? So we know AT. So area of the triangle is known to us now, which is half of r times r tan theta, correct?
Yeah.
So which is
Simple.
half r square tan theta, correct? And here we have r half r square theta. And therefore, the area of the shaded region will be area of the shaded region will be the we have to subtract one from the other, correct?
Triangle.
So we have half of, correct. R square is common, correct? And we have tan theta minus theta. Do you see that? So it's a very important formula which we have just not derived. So if you are given a situation where we have a tangent and something like this, that's the formula which you can use directly to find the area of the shaded region. Does it make sense to you?
Yeah, it's kind of similar to the area of the segment one.
Very good.
But it's switched.
Area of the segment, yeah, because tan theta can be more than one. You see that? Tan theta. So area of segment, right? So area of segment formula was what? Half r squared theta minus sine theta. You see that?
Yeah.
Sine theta is always less than 1. Radian measurements, right? Sine theta is always less than 1. So this will be a positive quantity in that case. You get the idea. Correct? Now, in any case, tan theta minus theta, this will be positive. So you correctly noticed this. So this value will be higher. So positive, I mean. So do you see similarity? Do you get the idea? Now, if you understand this part, that means what we have done is we have really understood how do we find the segment area using half r square theta minus sine theta.
Yeah.
Right. And we now also have a formula of how do we find the area between the tangent line and a triangle formed as given in question number 6.
Right, yeah.
So the idea is build your own library in which we have these type of questions one after the other and the formulas. And that's a beautiful question. Question number 8. Express area of the shaded region in terms of r and theta. Now, well, you can always substitute the values and calculate, correct?
Yeah.
Now, if you get the question number 5 in your exam, can you please read the question number 5, please?
Yeah. So the diagram shows points A and B on a circle with center O and radius r. The tangents to the circle at A and B meet at T. The shaded region is bounded by the minor arc AB and the lines AT and BT. So angle AOB, is 2 theta radians. Yeah. Okay, so part A. In the case when area of the sector AOB is the same as the area of the shaded region, show that tan theta is 2 theta.
Correct. So we are saying in the case area of the sector AOB, that sector, right? If the whole area is the same as area of the shaded region, correct?
Yeah.
And
Yeah.
that means even half will be same, correct? Half
Right.
of this and half of this will also be same, correct? Anyway,
Mhm.
so show that tan theta is really equal to 2 theta. So we, in this particular question, we are actually given the value of this part, sector, which will, so we can always do it, right? Because we know what is the formula for the shaded region, correct?
Yeah.
So, well, in this case, because this angle is same, theta, theta. Do you see that angle? 2 theta means what? This is also theta, right?
Yeah.
Theta, 2 theta.
Oh. Yeah.
Kind of, right? Do you see that?
Yeah. Yeah.
You can actually reduce the question to this question, saying this shaded region is equal to that shaded region, correct?
Yeah. Yeah.
So we can basically equate this to area of this sector, which is half r square theta, right?
Mhm.
You get the idea?
Yeah, I get it.
So
Yeah.
we are taking the half of this, correct? And this half r square theta, do you see this? Half r square theta cancel. You know, if
Oh.
you bring it on the side,
Yeah. On the same side, it cancels. Yeah.
yeah. So, and we get our result. So
I
you could
see.
actually, yeah, you could actually, that'd be 1 minus theta, and we can work it out. Anyway, so there will be something more than that, definitely, but you get an idea. How can you relate the two areas and get to this result? Is that clear to you?
Yeah. Yeah.
You can actually do it and prove that tan theta is actually equal to twice theta. Is that clear to you?
Mhm.
Perfect.
That's clear.
Yeah. So that's how you could do it. So, right. Now, here are some very complicated questions. Now, let me just jump on to simpler ones. I know those arc ones are very difficult, so we'll not go there for the moment, right?
Okay.
Let's take up question number 10.
Right. So the diagram shows a semicircle with center O and radius 6 centimeters. The radius OC is perpendicular to the diameter AB. The point D lies on AB. The point D lies on AB and CD is an arc of the circle with a center B. Part A, calculate the length of the arc CD, and part B, find the value of area of region P over area of region Q and give your answer to 3 significant figures.
Correct. You do get this kind of questions in your test also, right? So these are very parallel exam boards, and they provide you very good, questions. So what I feel is that if you do something from outside, you may expect these questions in your test, right?
Oh, right. Because they're not going to put the ones that we obviously revised in again.
Well, I have seen similar questions in both the places. So
I see. Okay.
it's like worthwhile to visit, this particular paper. You get the idea.
Right. Yeah.
So now, can you help me solve this particular question?
Mm-hmm. So calculate the length of the arc CD.
Okay, let's do this.
So,
Calculate the length of the arc CD. Simple as that.
yeah. So we've got the radius. So with center
R
O,
theta, right? How will you get R?
we know the radius is 6. Oh, don't you just do 6 squared at 6 squared?
Yeah, 6 square root 2.
6 square root
2 is the radius, right? 6 square plus 6 square square root is a right angle triangle. Isosceles with sides, leg sides as 6, and therefore hypotenuse will be, as you say, 6 square plus 6 square square root, right?
Yeah.
Which is 6 square root of 1 plus 1, which is 6 square root 2, right? So directly also, you could write 6 square root 2 as the radius, right?
Yeah. And then use that formula you wrote, arc length equals r theta.
We know the radius r is 6 centimeters here. So it's, okay, no. Sorry, radius 6 square root 2.
6 root 2. Yeah.
6 square root.
Times.
Yeah.
Oh, wait.
Square root 2. Correct. We are right. So that is what it is. So basically, it is an isosceles triangle, as you can see. And once we get the value of r, we know this theta. Theta will be what? These two are equal sides, right? So what is theta equals to? Pi by 4.
D. No.
Pi by 4, 45 degrees. because we have equal sides, right?
Oh, yeah.
So you can
And
say
the
tan theta is equals to 6 over 6, right? Which is 1, correct? So theta
yeah.
is pi by 4. So now once you know that theta is pi by 4 and r
7.
is 6 square root 2, you know the arc length. So you will get part A. Clear?
Yeah.
Now part B, can you please read that?
So we need to find the value of the area of the region P, divide it by the area of the region Q, and then you have to give your answer to 3SF.
Correct. So how will you find area of region P?
Region P. Um,
So we
so
can say
can
area of P will be
equals.
actually equal to quarter the area of the circle minus area of Q, right?
Yeah.
So we definitely, so it is 1/4 of pi 6 square, right? 6 square,
Well,
because
that's a
this
lot of
circle,
work.
a lot of work. Yeah, this question was
Yeah,
straight.
because it looks
6
easy,
square,
but it's
yeah.
not. Yeah.
AP is quarter of pi r square, radius being 6, correct?
Yeah. And then
Minus
subtract
area of Q. Is that clear?
Q.
Minus area of Q.
Yeah.
Then you get area of P, correct? So,
Yeah.
and then you have to find what is the area of Q, right? So area of Q will be, you have to see that this is your sector minus area of this
Well, the
triangle,
triangle.
right?
Yeah.
So it is half, R is 6 square root 2, right?
Yeah.
Square into theta, which is pi by 4, correct? Minus area of the triangle, which is half of 6 square, right? Length into width. Is that clear to you?
6 squared. Yeah. 6 times 6. Yeah.
So you should calculate AQ like this, and then you have to calculate AP as that, and then you can always do the needful, which is compare the two areas. Do you get the idea?
Yeah.
So as you are rightly saying, it may look simple, but there is a lot of work involved in it. You get the idea?
Yeah.
Correct? So that is how you're going to solve this. So what I'm trying to say here is that I'm going to share this video with you,
And
and
I'll go
you look
through.
into these questions, solve them, and get the answers for these. Correct?
Okay. Yeah.
Is that clear? Yeah. Can you please
I,
read question number 9?
yeah. Just a quick thing.
Yes.
Do
Yes.
you think with these kind of questions, especially the question 10, because there's so many like little shapes in between it, should we take out the shapes and draw them bigger alongside, or just work with what I'm looking? Because sometimes you can get
Yes.
confused
Yeah.
with
Yeah.
6 and 6
As
root
yeah.
2.
Yeah. Because you know the terms can be confusing when you read it, right? The diagram shows a semicircle with a center O and radius 6. So we should have stopped there. And we're talking about this semicircle, correct? And this radius 6. You get the idea, correct?
Yeah.
So that
Yeah.
means R is some other thing, right? It's not the radius of this circle. Correct?
Oh,
We
I
have to figure
see.
it out. And
Yeah.
therefore, we should go with what is R equals to? Well, R is 6 square root 2, correct?
So we
And what
can't
is
just
theta
assume.
equals to? So theta is equals to, this is an isosceles right triangle. So
Yeah.
theta is pi by 4. So as soon as we read, if we kind of dissect the whole figure as you're saying, we have useful information on the side. And now we
Okay.
read further. The radius OC, O2C, is perpendicular to the diameter AB.
AB.
So we know this is the right angle triangle, and that is how we got theta as pi by 4.
Right. Yeah. So when they put R there, was it just as a constant? It didn't mean radius.
It's just the distance between
So that could trick you
BC.
purposely.
So R is like BC, right? So BC is R.
Yeah. Yeah.
Right? It is definitely the length for the arc CD, right?
Yeah. Yeah.
Right. So for that, it is the radius. So now when you read the next line, which is
Oh.
the radius OC is perpendicular. We know this is the right angle triangle where the two parts are the radius of the semicircle. So 6, 6, and therefore we get the value of R, correct?
Yeah.
Then it is the point D lies on AB. So D is on the straight line AB. The point D lies on AB, and CD is an arc of the circle with center B. So now we know that radius is the arc radius for CD. And then we
Yeah.
can do calculate the length of CD. And then we'll do, well, CD is equals to R theta. We got both the things now, correct? We know R,
Right.
we know theta, we'll just multiply and get the first part. So this is done. You get the idea.
Yeah.
So if you read like this and do it, it is not very difficult. But otherwise, if we just go through it like we went and then get
Full
back
speed.
to
Yeah.
it is extremely difficult. So
Okay.
first
So we
read
just
the question so that you understand it all and then dissect and straight line by line, try to figure out the solution, right? And
I
then
get
solution,
yeah.
right? So then it's very easy. Then we say, find the area, find the value of area of region P over region Q. So we do have here, we could say, well, what is region, area of region P is basically equal to the sector minus, we have to take away the area of Q, right?
Right.
It
Yeah.
involves area of Q also. You get the idea, right?
Yeah.
So it's very tricky. So it is like,
Two unknowns. Yeah. In
yeah,
the
two
same
unknowns in the same
equation.
place. So you say,
Yeah.
well, it is related. So why not first find area of
Q.
Q, right? So
And
why
then
not
use that answer to
use
find
this
P.
here, right? Because we have to take away that
Yeah.
part. So if you think like this, it becomes logical, and in
Mm.
examination, you won't get confused. Otherwise, such
Right.
questions will throw you off.
Yeah. I hate the questions where they give too many words
Hmm.
and make too many sentences of it when you just need to sit there and kind of break it down, like you said. So
Correct. So
yeah.
break it down like this, it'll be very, very simple. So I hope that makes sense, right? Because,
Yeah.
we learn everything, but when we go to the examination hall, nothing clicks. Mainly
So true.
because, mainly
Just
because you're not
nerves.
thinking right, correct?
Yeah.
In
Yeah.
your home, in your classroom, you're like sitting
Comfortable.
with peace of mind and
Yeah.
no rush for time. You could do much better thinking.
That's
But in
true.
examination, you have to get used to this, time frame and the challenges which you are facing, some new questions which you have
Yeah.
never seen before. That was the idea of showing you this stuff, right? So you've
Yeah.
never seen such questions, and all of a sudden this pops up. And
Mm.
now when you look into your test papers, you'll find similar questions.
Okay. Yeah. And at least I'll see. It's like it will be familiar to me.
Yes. And now look
Yeah.
into question number 9. Let's see question number 9, please.
Okay. So yeah, let's dissect it. So the diagram shows two circles with center A and B having a radii of 8 centimeters and 10 centimeters respectively.
Mhm.
Okay, the two circles intersect at C and D, where CAD is a straight line and AB is perpendicular to CD.
Correct.
Okay, part A, find the angle ABC in radians,
Correct.
and part B, find the area of the shaded region.
Perfect. So first part is easy. Can you find the angle ABC? That means this angle. Yes.
So because we're told, is it just pi over 4?
Okay. It is tan theta, right? So angle ABC, let's say angle is theta, or not tan theta. What we know here is two sides,
Oh, 10 and
opposite
8.
and hypotenuse, right? So we
Yeah,
say,
yeah,
sorry, again, I'm writing tan. Sine theta, because sine theta will be 8 over 10, correct? So 8 is the radius of smaller circle, 10 is the radius of the bigger circle.
yeah.
So opposite side over hypotenuse. So we get the value of theta. Is that okay?
Yeah, yeah.
So we find theta equals to whatever. So we're done part A. Now we need to find the area of the shaded region. So you know this angle, and obviously this is symmetrical, correct? So we know 2 theta also. So we know 2 theta is twice this angle. Is that okay?
Mm, yeah.
And now we we know these two angles, and so we can actually find this is on that side, and this is like a semicircle. Do you see that semicircle? So from the semicircle, the small circle is a semicircle, correct?
Yeah, I can see it. So the
So
BC line, no,
area of
CD
this
line.
semicircle, yeah, half pi r square, half of pi r square is 8 square. Is that okay?
Yeah.
Half pi r square minus the area, which is this area, right? The whole thing, correct? Minus this area, correct? Will give us a shade, correct?
Yeah.
Yeah. So don't go for the full circles. Don't go for the full circles
Oh,
because the full circles are not matching.
yeah, yeah.
Semicircle is matching. This semicircle, this area, from that, I am taking away the segment area. I'm sorry. We have to take away the segment area of that. Sorry.
Yeah, that's clear. Yeah.
We have to take away the segment area. Segment area. So use the segment area formula for this. You understand? Only the
Yeah.
segment, which is half r square theta minus sine theta. Is that okay? Correct?
Yeah.
Where, let me not use theta, gets confusing. So let's use phi here. So this is 2 phi. Is it okay?
Okay.
Now it makes sense. Yeah, right. Now it makes sense, correct?
Yeah.
So that is how you're going to solve this particular question. So you have to kind of split it and use your formula, in the proper way. You have a lot of formula. Segment area formula can directly be used, and then you can figure it out.
Yeah.
Normally, what a student will do will find the area of the triangle, correct? Find the area of the whole sector, and then take it out, do the difference, get to this formula, correct? All
Oh.
those steps will be saved for you.
Yeah. Yeah.
Is that
Got
clear?
it.
Correct?
Clear.
So these are the type of questions, and I'm just sharing with you these solutions so that when you do tomorrow, you can actually quickly go through my solutions, check your answers, right? And see, does it make sense, right? So we have done all these questions, rather gone through them, just know what
Yeah.
the questions are. And you can pause the video to see what the solutions could be, right? And, we can then, if you have doubts on any of these, then we can discuss it later. Is it okay?
Yeah. Yeah.
So that's the whole idea. This question I purposely left because there are some concepts which I really want to discuss with you later. But
Okay.
anyway, now you can go through the solution of this particular question also, understand the concepts which I really wanted to teach you. But if you go through it once, it'll be better for me to explain, right?
Oh, okay.
So there are a lot of concepts in this particular question. So I'd like you to go through
So
this.
question 7.
Yes, yes.
I'll just note that.
Correct. So it's a different kind, right? So based on this, we have some other questions also. These are also seen in your senior UK competition. They combine a lot of things together to give you some questions. This is what we just now did. Do you remember this? This is what we just now did.
Yeah.
So you can figure this out, and that also we kind of solved, right? So these are the solutions of the questions which we just went through. However, quickly, if you just have a glance of that, at least you'll get a hint. You'll not get stuck. That's the whole idea. Get the idea?
Right. Yeah. Yeah.
Perfect. So we'll end our class here today. Let me see what your views are and what did you learn today? Can you summarize?
Yes. So we kind of looked at questions that we didn't really cover in, like, we've seen like similar questions, not in terms of the way you laid it out today, because they were quite interesting diagrams and they were more wordy. So what we learned was to kind of like dissect the question statement by statement and kind of work with that individually. And if you need to take out different images from the diagram, because it can get quite complicated to know which ones you're trying to look at. Especially that last one that we did with the semicircle and the sector, that was quite hard to see. But yeah, you need to make sure that you, like, when you do something, it needs to be like accurate. Because when I said just to do the whole circle, I wasn't considering my sector wasn't taking account of the other parts of it. So I need to make sure that the semicircle, it did cover that part. So you just kind of need to be aware of the different things. We also learned that new formula of when you had like a circle and then a tangent to it. It was the half r squared tan theta minus theta. It's similar to our area of a segment. It was just different because of the tangent part and instead of like a chord. But yeah, now I've made like a little sheet of all these formulas. It's really handy now, so I don't have to kind of waste time doing all of that when I know straight away this is the formula, and it's really easy.
You'll save half the time. For every question now related to circles and tangents and areas and sectors, you're going to save so much of time that comfortably you will be able to complete the paper. Otherwise, we are always in a rush to complete such a paper, right? So that will be avoided. That's the whole very big advantage. Perfect.
And I feel really good, like when I have time to go back and check, because then it like clears my mind. I feel a bit more relaxed. I can think clearly. So I like to go in quickly, just trying to answer as much as I can, and then save that time for these other harder questions.
Yes. So I'd like you to actually solve these questions, 10 of them, which I shared
Okay.
with you, and also questions from your book. Next time, we'll share all the difficulties which you had. That'll be good, right?
All right. Okay. I'll send it to you, and then yeah, we can go through them.
Okay, great. Have a good
Cool.
day.
Thank you
Thanks.
so much, sir. Have a good day as well. Thank you. I appreciate
My
it.
pleasure. Thank you.
Bye,
Bye.
sir.